Guys, so welcome back to the channel. And in the last video, last big video, we discussed about some questions in binary search. In this one we'll be talking about some 2 or 3 questions that I wanted to discuss in sorting, right? So it may or may not use sorting exactly the algorithms that we want to use, but it does involve the implementation and logic if we know the logic of if we know the application of sorting. So let's get to the first one. So this one is asking us to return the maximum product of 2 elements inside the array. So it's saying that return the maximum product of the element 2 elements I and j when you subtract it by 1. So in the first one 3 4 5 2, it's giving us the answer as 12. So how that's working, we'll be talking about that. So let's go to the whiteboard and let's discuss as to what we are supposed to do. Alright, so let's create the array 3 4 5 and 2. Okay, and we are asked, as the answer is 12, we are asked to give the maximum product. This is the product which we are getting by multiplying the biggest 2 integers inside the array, which is 5 and 4. But 5 and 4 is not 20, we need to subtract 1 from each. So if we subtract 1 from each, then it will become 3 and 4, and we are asked to return the product of this. So that is equals to 12. So basically, in a way, it's basically asking us to find the 2 biggest elements, the first largest and the second largest element inside the array, and then return its product. But before you return it, you subtract 1 from it. That's what the question is asking us to do. So now the first thing that should appear inside our thought process should be that it's asking us to multiply the first and second largest element, right? That's what it's asking us. So let's say this array was sorted. So then in descending order, let's talk about descending. We'll be taking the descending order 5 4 3 and 2. So if this array is sorted, then we take the first and second element, which is 5 and 4. We subtract 1 from each, which gives us 4 and 3. That's correct. And then we multiply this, which gives us 12, and we return this answer. This is our answer. So it's very easy. We just need to sort it, right? That's what the application is asking us to do. We sort the given array in descending order, So let's say we can use bubble sort. By the way, you can use any of the sort algorithm that we have learned till now. We can use bubble, we can use selection, not everything. If you remember, you can't use cyclic sort because it needs to be in a range of 1 to n or 0 to n. Basically it needs to be a range from 1 to n, so we can't use that. So we can't use cyclic. We can use bubble, we can use selection, and we can use insertion, right? That was the fourth one. Yeah, we sort this one in chunks. Yeah, selection sort we can apply over here. All of these 3 are gonna give us the time complexity of big O of n square. Yeah, that's correct. Cyclic would, if it was applied, then it would be giving us big O of n, but no, we are not applying that one. So we can use bubble sort. So let's say we used the bubble sort in descending order. Let's take a small revision about bubble sort as to what the logic was behind it. Yeah, we would take, this was our original array 3 4 5 and 2. We would start the outer loop from I. This was I. It would run n times, and within it would come a j loop, which would start from first index. It would compare that if j would be greater than its previous position. Is that correct? Is that condition satisfied? Then we would swap it. But this condition is for ascending order. Yeah. So for descending order, we simply need to change the parity. So if j was less than its previous element, wait a second, I just need to check. If j is greater than j minus 1, then we swap it. No, my bad. This is for ascending order, this is for descending order as well. Alright, so we do this one. If the jth element is bigger than its previous element, sorry, my bad. So we won't do ascending. So if jth element is greater than its previous element, then we swap it. That's correct. So we swap it. We do this every time for n times. So we get big O of n square. That's correct. And in the end, our array would look something like this. Phi. Then so if we do a dry run, then it would swap the phi and 3. Means it would swap all the biggest elements from first. So it would swap phi, then 3, 4, 2. Then in the second one, it would be doing. It would look something like 5, 4, 3, 2. And then these two would be actually in its correct place, but it wouldn't check if we provided a swap boolean. I hope you remember that we discussed about that boolean variable, that it's simply just applying the condition that if we don't swap it, then we simply need to break that iteration, not the entire loop. We don't need to return it, we will go all the way, but we just don't swap it. So we don't even need to go further if we don't swap it. So we'll be skipping that iteration and we'll be moving on with the next one. So basically that's the main application of bubble sort. It will sort in case of descending order, it will sort all the smallest elements in its correct position first. Yeah. Okay. So this is our array, and when we return the answer, we are basically asked to return the product, right? So we can simply declare an answer variable. Int answer is equals to, we'll be returning the array of 0 minus 1. So basically this would be equal to 4, because array of 0 is 5 minus 1 is equals to 4, into, we'll be doing the same thing with the first element, minus 1. Yeah, so this is 4 minus 1 will give us 4. So this is what we are asked to return, right? So we don't even need to declare the answer variable, because there in the end we are simply returning it, right? So we are return answer, but we can simply do a direct return as array of 0 minus 1 into array of 1 minus 1. That's correct. So both are okay. It's just a simple shorthand property. Okay, so this is basically bubble swap. So by the way, what will be the time complexity for this one? See, in the end, when we sort the array, we are simply talking about getting the constants, array of 0 and array of 1. We are simply taking the constants. That is big O of 1. That does not need any iteration. Where the iteration is required is over here, where we are taking two loops. These two loops will be taking big O of n square, as we discussed. Yeah. Now, so the entire time complexity for this type of solution will be big O of n square. Yeah. So is there any way that this complexity can be reduced? Let's say it could be reduced to big O of n, maybe. If we talk about big O of n, meaning we only iterate this from 0 to n and we get our required answer. Now let's think about this. Do we even need to sort this array? Are we even using all the elements that are after the first and second element from the sorted array, from the descending order sorted array? because see, we are the only reason we are even sorting this array is to gather the first and second element. We don't even need to use the all the elements that are coming after it in the sorted order, right? So why even sort the array if you are just going to use those first two elements? And basically, what are those first two elements? Those are our uh, maximum element and the second max. We can simply put a variable name for those. So they are our max and second max. If somehow we manage to get the data for the max and the second max variables, then what do we have to do? We simply, so let's say these are our elements. If somehow we get the information about these two values, then what are we returning? Basically, we are simply returning max minus 1 into second max minus 1. Yeah, that's what we are doing, right? Because this holds the value of the max element, this holds the value of second max element. So to be honest, we don't even need to sort the array just to get the information for these two. That was the let's say that was the brute force approach, where we sort the entire array. We can even sort this in ascending order and then get the value of last two elements, because the biggest and second biggest elements would be present in last if we sort it in ascending order. So we don't need to do that just to get value of these two elements. What we can do, let's say this is our optimal approach. We can take an answer variable like we did in the brute force approach. We are simply returning the answer as 0 as of now, or maybe we don't even need to declare it. For the second and third which variables which are max, we can declare them minus 1, and in second max I'll do sm max is also minus 1. Now these are our counter variables. We can simply keep on updating them as we move to the array, through the array, right? What we'll be doing now is that, let's just make sure our partition is correct. Okay, so all right, so I'll be writing the same array, the 3 4 5 2 in a bigger order, in a bigger font and better spacing, so it gets clearer as to what is happening. All right, and this is our 0th index, first, second and third. All right, so in the beginning our max and second max are both minus 1, right? Here at the minus 1th, at the minus 1 index, basically before the 0th index, which is not even present in the array, we are just taking it as minus 1. So in the minus 1, before we start through the first iteration, our both the variables values are minus 1. Now we compare. We will be comparing both the elements to each of the elements, right? One by one. See, let's talk about comparing it with the first element, which is 3. We'll be comparing the biggest element. Means what we want to find the max element. So we will be comparing if max element is less than the 0th index, which is 3, by the way. So if that is the case, then what do? We'll be taking that value inside the max. So max is equals to 0th index. Yeah, that's what we did. This was our first condition. Now what our second condition, because we also need to update the second max variable, right? So if our second max is less than max, it should always be that case, and also this second max variable is less than the element. That's correct. If both of these conditions are correct, then we need to update that second max variable. Then second max is equals to that element. So every time these two conditions will keep on running, the first and second, we'll be comparing the max always first, because we need to make the bigger element, make sure that the biggest element would fall into the correct variable, which is max. Then we check that if second max is less than max and the variable at which we are at, the element at which we are at, is greater than the second max. So if that is the correct, means basically what this condition is saying us is that this element is less than the max element, but it is greater than the second max. So if that is the case, then we need to assign this value to the second max. That's what this condition is saying us. Yeah, that's correct. So if that is the case, then what do we need to do? We need to simply swap it. Not swap it, we just need to make sure that the elements go into that case. Now how do we write this code? This is the pseudo code, but when we actually code it, it should look something like, the conditions would look something like, if max is less than the variable iterate and that element at that point of time. If that is correct, then first of all we will be assigning that this value to max is equals to that element. And to even simplify this condition, what do we need to do? Once we assign the biggest element to the max, before that we can also assign, if this element is going to be bigger than max, then basically it also means that this element will also be bigger than the second max element. That is correct. And if that is the case, we know that is the case, then we can simply assign the max value to the second max before we do this. So let's erase it and write it in a better way. Okay, so if this is the case, then first of all we found the element that is bigger than max, right? So our second max needs to be updated first before we update the max, and then we can update the max with this element. Yep. And then if that is not the case, means if the element is not bigger than max, means if the element else if the element is less, if max is greater than this element but it is greater than the second biggest element, because means sm is less than this element, then what do? We simply assign sm as this element. We can't always update the max and then we keep on updating, because here what is happening, both are getting updated. We can't do that every time. But if we somehow find a case where this is true, means what I told earlier, means that element is less than max but it is greater than the second max, then we simply update only the second max. But in case of first condition where the max is only smaller than the element, then we need to update both. So this is basically our main iteration loop, and this will run till big O of n, because we only need to run this one time. It will go from O to n, and we found our two biggest elements, and in the end we can simply return answer is equals to max minus 1 into second max minus 1. Yeah, that's correct. So let me write the code for both the solutions and I'll explain you what actually happened. Alright. Okay, so this is our first case where we sort the array in descending order. We take a boolean value. We'll not always check if it is if the boolean value does not changes its boolean value, that if the swap does not change its value, then that means that iteration is already sorted, so we will simply break it, and otherwise we can simply swap it, the same thing we always been doing. And then we can first of all we will be updating our bubble sorting nums, then we'll be taking the first and second variable, and then we simply return the answer. The first and second variable all are already taking in -1 in account, so we don't need to do it over here in the answer, and this will give us the submitted value. Once we submit it, it will give us solution, in second. Oh, okay, so I don't need to take this for now. I'll not I'll make sure that these are not in the account. Okay, so you can see that it's getting accepted, but it is very less in time complexity. So it's only beating 6.58%, right? So we don't need to do that. We don't even need to sort it. All right, so here we'll be completely erasing this answer. This is our new final answer, which takes in the max and second max. Basically, like I said, we declare the answer as 0. The first and second variable, max and second max, are both -1. We'll be iterating only once, and then we check if max is greater less than the variable, then we update both the variables, max and second max. Else, if only the second max is less than the element, then we only update second max, and in the end we will be separating one from both these variables, and we simply return the answer. All right, so we'll be calling it int answer. I'll just make a answer variable. Answer is equals to max of nums. Nums, and we can simply return this answer. Maybe I think this one will be enough to hold the answer. Yeah, see, now it's actually beating all 100% complexity. So you can see that this is how it's done. We talked about the brute force solution, which is big O of n square. We talked about the optimal solution, which is simply big O of n. Maybe in the future we'll be talking another maybe better answer, which requires dynamic programming or maybe greedy method, but for now it's getting accepted and it's beating 100%. So I guess maybe this is some sort of dynamic programming if you think about it. All right, so we'll stop over here for the first program. We'll be getting back to the second question now. All right. Okay. All right, so let's get to the second question. It's saying find the duplicate number. uh, Given an array of integer nums containing n plus 1 integers, where each integer is in the range 1 to n. Now the main thing it's saying is that it's a range of 1 to n, and there is only one repeated number in nums, and we have to return this repeated number. So we must solve this problem without modifying the array. Yeah, okay. So basically it's asking us to not use any extra space. All right, so the first example saying 1 3 4 2 2, and the output is 2, right? All right, so we'll be using that example only. Okay. uh, okay, so let's start with the example. All right, so we are saying that we have an array of 1 to n, integers from 1 to n, having n plus 1 numbers. Now what this basically means, if is that if there are n numbers, then one number is getting repeated, and that's why the n plus 1 is the extra number that is present in the range of numbers. So our array could be like 1 3 4 4 5 and 6. So one, yeah, so that this is an example of the array we'll be taking here. So here 4 is basically getting repeated, right? And we are asked to return this 4. Okay, so let's talk about the indexes. So this is 0, this is 1, this is 2, 3, 4 and 5. Now you can see there are 6 elements and there are 6 integers, but one is getting repeated, which is 4. Now in the question it's clearly saying that it's present in the range of 1 to n. It could be 0 to n or 1 to n. It's saying 1 to n. Now if you remember that in sorting, if there is a range given between 1 to n or 0 to n, a whole number range, then we should be thinking of applying cyclic sort. So let's say we applied cyclic sort, because cyclic sort will only be working if there is a range of numbers present from 1 to n or 0 to n. So let's say somehow we uh, sorted it using cyclic sort. So 1, 3, 4, okay. So alright, so my example is already sorted. So that won't be the case every time. I should have changed numbers bit here and there. So alright, this is our index. This is our main sorted array. We'll be taking this array now. So the range indices here would be 0, 1, 2, 3, 4 and 5. Okay. Now we know that the application of cyclic sort is such that whatever the index, if we are given the range of 1 to n, right? We are considering 1 to n range. So whatever the index we are in, the element at that index should be index plus 1. So at this index, the element should be index plus 1. That is our main comparison. That's our main comparison when we talk about cyclic sort. Every time we find about every time we compare this main condition, because if this condition is not satisfied, then we'll basically changing the index with the ith iteration when we run the loop one time from 1 to n, from 0 to n basically. So if that's not the case, only then we will be swapping. So every time we are checking that if this index means 0 is equal to 0 plus 1 or not, means that index plus 1 or not. So if that is the case, means this element is in means this element is in its correct position, right? That's what we have been checking every time. Now if that is not the case, meaning I think there is some issue, because in my example I should be taking, instead of 6 there should be 2, means instead of here there should be 2, because I might have made some small error. Yeah, wait, why not rather take the exact same example that we'll be using? So 1 3 4 2 2, we'll be taking that example only, because I think I might have made some error in considering the correct array to be used in 1 to n. That's my fault from my side. 1 3 4 2 2, 1 3 4 2 2. All right. And once this array is sorted, then it would look something like 1 2 2 3 and 4, right? That's the way that we want the array to be after it's sorted. Right, now let's talk about the indexes over here. 0 1 2 3 and 4. So the same logic applies over here. If that index is equal to, not the brackets, we don't need the bracket when we talk about just index. If that index is equals to index plus 1, the element, so this is matching. If the index is 1, then the element should be 2, which is correct. If the index is 2, then the element should be 3 over here, right? That should be the case. And since that is not happening, you can see that all the elements after it are also not following the rule. You can see, if you can spot the pattern, like if the index is 3, then the element over here should be actually 4, but it's not. Why? Because we have some extra element, the duplicate element over here. If the index is 4, then the element over here should be 5, not 4, right? But it's giving us the same element and same index, which is only possible if somehow there is a repeated number that is not allowing the index and the element to merge with the condition. So our trick over here should be, as soon as the first element which violates this condition, this index plus 1 element should, if that gets violated at any index, then we simply return the element over here, which is 2, right? This 2, not the first 2, because the first 2 is not violating the condition. So our let's say I'm not going to explain the cyclic sort again. I'm not going to explain the application and the code behind the cyclic sort, because we are simply swapping the indexes when it's not satisfying this condition, right? So let's say our array is sorted. We'll simply this question is not about sorting using cyclic sort. It's about using the application of cyclic sort. That's what the question is asking. So it's asking us to use the logic of what we do in cyclic sort. So our main for loop which will be running to find this element, this duplicated element, should be like, it would be running from I equals 0 till n and I plus plus, that's basic, yeah. So it should be asking us that if the element means at that position, let's take nums at I is is wait so yeah, is not equal to the index, means index minus 1, um, nums at 0. If we are considering wait let me rewrite the condition, because I might have made some logical error. um, if I is not equals to nums of I plus 1, yeah, I- that's what we are trying to do. That if this condition is not getting sufficed, means if 1 is not equals to 2, means if 2 is not present at first index, then we simply return 2. Means if these two are equal, if at any point they become equal, we can also put a condition like that as well, that rather than putting this, we can also put something like if means when the third index, right here at the third index, so when I is 3, the element should also be 3. So if I is equals to nums of I, if somehow this is what's getting us as the result, then we simply return nums of I. Yeah, we can also use that condition as well. So basically this all code logic is what you can figure out. We can use it two ways. If means if the index is less than the element by 1, then it's correct, but if that gets violated, then we simply return that element. Or we can also use this condition, like I said, that if at any point the index becomes the element, means the value of index is equal to the value of element, then at that point we can simply return the element, right? So either ways you can do it. So let me write the code and we'll be testing it, and we'll see what the time complexity and all about this is, because it's not that hard to understand the application, right? So I'll write the code and come back. Okay, so this is what I wrote. So I simply so I'm not going to write another swap function. I just put the swap over here. So this is a this till here. I even wrote a comment over here that till this part of the function, it's saying that the array is sorted. So after this, means this is all about the cyclic sort. That's what we've been doing, that if it's going to swap if the condition isn't suffice. And what is the condition? That if the correct index is not equals to the element at that position, right? And the correct index is 1 less than the element at that position. So yeah, once the array is sorted, we'll be using the application of cyclic sort. Similarly, we'll be looping through 0 to I will be iterating the entire array, and we'll check at every point if at any point the index, means the element at that point, is not equals to the element index plus 1. Means what I'm trying to say, if this element over here is not equal to the index plus 1, that's what we will be checking every time, right? See over here, basically I use this condition. We can also use this condition because both are trying to apply the same logic, right? So if that is the case, if at any point this condition is not getting sufficed, then we simply return that element, right? Or at the end we just need to return -1, meaning there are no duplicates. Now what I want to emphasize over here is, when you solve lead codes and all, there are going to be edge cases, right? So when I say I wrote -1 over here, the -1 basically means that there is nothing to be returned. Means if you are returning -1, then that means there is no duplicate present in the array, and we need to take care of those such situations, because it is possible that we are given an array which may or may not be sorted. That doesn't matter, but what matters is that there is not a single element that is duplicated. So that's why I wrote -1, and such cases are called edge cases, where you simply know that if nothing is going to work, then it basically means that the array is sorted and we don't need to check further much, because all our while loop and for loop are getting iterated once, and if everything out of, even if those are not returning anything, then it basically means that the array is sorted, present in a range of 1 to n without any n plus 1 integer. That basically means that. So, and also to just to suffice the function, because we have to return something, right? So even for that case I'm returning -1. All right, so let's submit and see what the time complexity and space complexity is. All right, so it's beating 44.2% in time, yeah, and 38.5. Okay, all right, not that bad. So by the way, I'll be making a separate video of one full uh, lecture about time complexity and space complexity later on in the future, because I would like to emphasize that it may or may not be asked in your interviews, but it's very important that you understand the logic behind time complexity and space complexity. What space is, what auxiliary space is, what are recurrence relations, some formulas to find out time complexity of each algorithm you are given. All those things are very important. So, and it's going to help us to understand that how can we use this 44.2% to increment it, because there are some cases over here like that are even better than ours, right? That's what we'll be seeing. So by the way, I'll be making some videos about it in the future. For now we'll be moving on to the next question. All right, so all right.